channel Knowledge Hub. Please subscribe to our channel and turn the bell icon for the latest update. Today we're gonna start with your physics class 11. That is your class 45th class of the session, and that what is being important one as well. And we'll go ahead and that we discuss about it in a detail. That is your unit 5, which is laws of motion. That is very important one. In terms of unit 5, laws of motion, where we had done your 44 class, wherein that we had done your friction, rolling friction with their numerical as well. Today we'll start discussing about the circular motion, which is very important one. So without wasting our time, we'll start discussing about it. Circular motion, that is very important one, and stay tuned with us and please like, share and subscribe so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So for circular motion here, in that we have seen in the last chapter that we discussed that the acceleration of a body moving in a circle of radius r with uniform speed v is v square by r, that is directed towards the center, and according to the second law, the force F providing this acceleration, which is your Fc equals to mv square by r. Okay, so here where m is the mass of the body here, and a force directed towards the center is called the centripetal force. Where for a stone rotated in a circle by a string, and a centripetal force is provided by the tension in the string, and that centripetal force for motion of a planet around the sun is gravitational force for the planet due to the sun. And for a car taking a circular turn in horizontal road, the centripetal force is the force of friction. With the circular motion of a car on a flat and a banked road give interesting application of the law of motion that we'll discuss here one by one. And on the same way, if we are going for it, motion of a car on a level road that we discussed here. So let's go for it in the detail. Motion of a car on a level road. So for that here, which we discussed here, so for that we go for it. The three forces act on the car, and that we have as follows. So for that, when we are going for a physics, when we are solving a physics, you have to be considerate about it and all the points related to the physics. So three forces act on the car. The first is the weight of the car. The second is normal reaction. And the third is frictional force. As there is no acceleration in the vertical direction, so n minus mg equals to 0, where n equals to mg. And the centripetal force that required here on the same way, that the centripetal force that has been required here for the differences that we discuss about it. Required for circular motion, that is along the surfaces of the road, and the provided by the component of the contact force between road and the car tires along the surface. This is by definition is the frictional force. You have to note that that it is a static friction that provide the centripetal acceleration, and static friction that opposes the impending motion of the car, that a car moving away from the circle. And using this equation, the result we have is equals to us in mv square upon r. V square is equals to mu s r n upon m mu s r g. So which is independent of the mass and of this. So this shows that a given value of mu s, and there is a maximum speed of a circular motion of the car possible, namely v max equals to under root mu s r g. So that is now let's discuss motion of a car on a banked road, that we have to discuss here. You can copy down all these things. Motion of a car on a banked road. So for that, it is we can reduce the contribution of friction to the circular motion of the car, and if the road that since there is no acceleration on the vertical direction, and that the net force along with the direction that must be 0. So hence for that it will be n cos theta equals to mg plus f sin theta, and the centripetal force that is provided by the horizontal component of n and f, n sin theta plus f cos theta equals to mv square by r, but f is less than equals to mu s n. Thus obtain v max, we put f equals to mu s n, then the equation thus become n cos theta equals to mg plus mu s n sin theta. Now for the n sin theta equals to mu s n cos theta equals to mv square by r. From this equation we obtain n equals to mg cos theta minus mu s sin theta. Simulating value of n in the equation, we get mg sin theta plus mu s cos theta upon cos theta minus mu s sin theta equals to mv square max upon r, or v max equals to rg mu s plus tan theta 1 minus mu s tan theta by half. So comparing with this with the equation, and we see that the maximum possible speed of a car on a banked road is greater than that of a flat road. So for mu s equals to 0 in this equation. So we get mu v0 equals to rg tan theta. As this is speed here, that the friction force is not needed at here. So for that here we'll discuss about it, and now here for this, that comparing the equation we get the value here. As this speed, friction force is not needed at all to provide the necessary centripetal force that driving at a speed or on a bank road over the falls of the little wear and tear of the tires. The same equation also tells us you that for V less than VO, that is the frictional force will be of the slope and that of the car that can be parked only if tan theta is less than equals to mu s. Now we go for another question that has been important one, and which is related to this only, this topic, circular motion. So we go for it. The question is, a cyclist speeding at 18 km per hour on a level road, taking a sharp circular turn of radius 3 meter without reducing the speed of the coefficient of static force between the tires and the road is 0.1. Will the cyclist slip while taking the turn here? So that we go for it, and let's figure it out. This is your 10th question. So cyclist speeding at 18 km per hour on a level road, takes a sharp circular turn of radius 3 meter without reducing the speed the coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip while taking the turn? So here on an unbound road, a frictional force alone that can provide a centripetal force that is needed to keep the cyclist moving on a circular turn without slipping it. If the speed is too high, or the turn is too sharp, that is the of too much of radius, or both, the frictional force is not sufficient to provide the necessary centripetal force, and that the cyclist slip. So the condition of the cyclist is not to slip, that will be we have. So for that, v square less than equals to mu srg. Now r equals to 3 meter, g equals to 9.8 meter second square. You have to take it, and mu s equals to 0.1. So that is mu s rg 2.94 meter square second inverse square. V equals to 18 km per hour, which is equals to 5 meter per second. So that is v square equals to 25 meters square second inverse square. The condition is not obeyed, so the cyclist will slip while taking the circular turn here. This is what we have. Now we go for another question that comes under the circular motions itself. But other than that, we discuss about some of the numericals here. Other than numerical, we'll discuss some of the questions related to it. So that is a very important one as well. So on the same way, before ending it up, we'll discuss some of the questions. So that will helpful for you as well. So we'll discuss the 10th questions here today. So for this, that is we had done your 10th question. So now today we'll discuss about 11th question. 11th question is the truck starts from the west, acceleration uniformly at 2 meter per second inverse square, t equals to 10 second, and a stone is dropped by a person standing on the top of the truck, which is 6 meter high from the ground. What are you have to find out the velocity, acceleration at the stone at t equals to 11 second. You have to neglect the air resistance as well. Now coming towards the 12th question of the series that I had given you, the question is a bob of mass 0.1 kg hung from the ceiling of the room, and the string 2 meter long is set into the acceleration where the speed of the bob and the mean position of 1 meter second inverse. What is the trajectory of the bob in the string is cut when the bob is at one of its extreme position or as its mean position? Another is the 13th question we discuss about it. That is a man of mass 70 kg stands on a weighing scale in the lift, which is moving upward with a uniform speed of 10 meters second inverse square. The second is downward with a uniform acceleration of 5 meters second inverse square, upward with a uniform acceleration of 5 meters second inverse square. What would be the reading of on the scale in each case? And what would be the reading if the lift mechanism failed and it hurled down freely under the gravity? The 14th question we have is that shows the position of the time graph. You have to find out the force of a particle. And the 15th one is that two bodies of masses 10 kg and 12 kg respectively kept on a smooth horizontal surface are tied to the ends of the light string, and a horizontal force F here where 600 Newton is applied, and that is and B along with the direction of the string. What is the tension in the string in each case? Another question we have here, which is your two masses 8 kg and 12 kg that are connected to the two ends of the light in extensible string, and that goes over the frictionless policy. Find the acceleration of the masses and the tensions of the string when the masses are released. 17th question, a nucleus is the rest of the laboratory frame of reference, and show the distinguish into the two smaller nuclei, and the product must move in opposite direction. 18th one is two billiard balls, each of mass 0.05 kg, moving in an opposite direction with a speed of 6 meters second inverse square. Meters second inverse, and that collide and rebound with the same speed. What is the impulse imparted to each ball due to the another? The 19th question, a shell of mass 0.020 kg is fired by a gun of a mass 100 kg. If the muzzle's speed of the shell is 80 meters second inverse, then what is the recoil speed of the gun? The 20th one, a batsman deflects a ball by an angle of 45 degrees without changing its initial speed, which is equals to 54 km per hour. What is the impulse imparted to the ball? Mass of the ball is 0.15 kg. 21st question, a stone of a mass 0.25 kg tied to the end of the string with a whirled round on a circle of radius 1.5 meter. With a speed of 40 revolution per minute in a horizontal plane. What is the tension in the string? What is the maximum speed which the stone that can be whirled around if the string that can be whistled, and a maximum tension of 200 Newton. If in this that the speed of the stone is increased beyond the maximum permissible value and the string breaks suddenly, which of the following correct describes the trajectory of the stone along the string breaks? The first is the stone moves radially outward. The stone flies off tangentially from the instant of the string breaks. The stone flies at an angle with the tangent whose magnitude depends on the speed of the particle. The another one we have is you explain why a horse cannot pull a cart and run in empty space. And the second is the passengers are thrown forward from their seats when a speeding bus stops suddenly. Third is it is easier to pull lawn mower than to push it. And the D1 is that the cricketer moves his hand backward while holding a catch. So now we'll discuss the rest in the next summer class. That is your additional exercises question. So here we're going to end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.